Today we are going to study about the projectile motion. To learn about the projectiles, we must know first the Newton's equations of motion. So there are some few equations of motion available. Final velocity, and Vx square, Vi square plus 2As, and the distance s equal plus of a t square, that means delta t square. So these are the three important equations which will be used in the projectile motion. So in projectile motion, suppose the body has been thrown through an angle theta, so it will be like this with a velocity v. So this is the x component, vx, and this is the y component, it will be vy. So with that angle theta, so this will be equal to v, otherwise we can say that it is with a velocity u. So this is the x component. So x component means u sin theta, and this will be u, sorry I committed a mistake, so it will be, the horizontal component will be u cos theta, and the vertical velocity will be u sin theta. So the important thing is the vertical component velocity will change according to the time, and the horizontal component velocity will remain constant. So now we are going to study about the maximum height reach. This is the maximum height. So for the maximum height reach, we will use this formula. So first one, maximum height reach. This is called h. So we can use the formula Vf is equal to Vi square plus 2As. So at maximum, the final velocity will be equal to 0. That means this velocity will be equal to 0. The initial velocity will be the y component. That means u sin theta whole square is going up, so the acceleration will be negative g. So a will be negative g all the times in a projectile motion. So it will become 2g height. Now you can equate this equation by simplification. 0 is equal to u square sin square theta negative 2g height. So 2g height will be equal to u square sin square theta. So our aim is to calculate the value of h from this equation. So h is equal to u square sin square theta over 2g. So this is the maximum height attained by the projectile motion, a projectile body. The second one is, this is number one. The second one is time taken to reach the maximum height. Let it be t1. For this we will use this formula. Vf is equal to Vi plus a delta t. So time taken, as usual, at maximum height the final velocity will be equal to 0. Vi will be equal to u sin theta, and a will be negative g delta t. So for us, in this case, we have to put t1. So g t1 will be equal to u sin theta. So t1 will be equal to u sin theta over g. So this is the time taken to reach the maximum height. Number 3, time taken to fall on the ground. This should be, now the particle is here, this is t1. When it is fall on the ground, it will be twice of this one. But we cannot say like that. We have to prove mathematically. So for that purpose, we can use this one. At the time of fall, the height distance, that means this tells us the height, this will be 0. So here the s will be equal to 0. So you can use this formula. Initial velocity, we can say u sin theta time. At the time of fall, we can say t2. As I told you, a equal to negative t, 1 over 2 g. So instead of that one, we can put t2 square. Now we can equate 1 over 2 g t2 square will be equal to u sin theta t2. This t2 and this 1 over t2 will be get cancelled. So cross multiplication g t2 will be equal to 2u sin theta. So finally we got the value t2 equal 2u sin theta over g. As I told you, it will take twice of this time, u sin theta over g times 2. The last one is range. Normally they are called as R. So range means from this distance. Suppose it is a bullet, how far it has traveled. What is the range of the bullet? Like that. Sorry, the range of a gun. So we know the velocity is equal to rate of change of distance. So distance over time. Actually this is the distance is the range. So this is the range we can say. R is equal to velocity into time. In this case, important thing is all this time we use the vertical component. Now we are going, because it's a range, we have to use the horizontal component Vx. So Vx cos theta time, at the time of fall we know that it is t2. We already found the value of t2 here. So v cos theta, we have considered u, so it should be u cos theta, that is the horizontal component velocity, u cos theta times what is t2? We have 2u sin theta over g. I arrange the equation, I make it 2 sin theta, this one sin theta, and next one is cos theta, then u times u square over g. We know that in trigonometry, we know sin 2 theta will be equal to 2 sin theta cos theta. So 2 sin theta cos theta can be written as R equal 2 sin theta cos theta will be equal to sin 2 theta, and there will be a u square available here, u square over g. That is the formula for range. So just I would like to brief you. So this is a projectile motion. A particle has been thrown with an angle theta. So we are going to calculate the maximum height reached. So we used the second equation of Newton's equation of motion. The important thing is at the maximum height Vf will be equal to 0, and finally we got the value h is equal to u square sin square theta over 2g. Now we found that the time taken to reach the maximum height, we use this formula, and finally we got the answer t1 is equal to u sin theta over g. Time taken to fall on the ground is, yes, if it is 5 seconds, it will be 2 times 5, 10 seconds. So we got correctly by using the formula. Which one? This one. Yes, equal VAT of A delta t. We can use the word delta t is called. Okay. And finally we got that t2 is equal to 2u sin theta over g. That means twice this value. And finally the range. So the range is distance, velocity time times. In this case, we use the horizontal component. The horizontal component velocity is equal to u cos theta. We use the u cos theta, and time to fall on the ground is t2. We already know the value of t2 and put the values correctly. And after that, we know the formula. The value of sin 2 theta is equal to 2 sin theta cos theta. We substitute the value, and finally we got the range u square sin 2 theta over g. So these are the 4 important formulas important for the students to understand the concept of projectile motion. Thank you for watching my video. See you in the next video. Bye.